Alright, so let's look at how the PowerPoint unfolds for this here. So they show you that normally we reduce the standard deviation over n. Because we don't know the population standard deviation, we have to use the sample standard deviation. So they're showing you this is where your t-statistic comes from, which I just showed you. And they go ahead and do the do step. They get this 1.54, and then we see if they want to know where t is greater than or equal to 1.54 because it's more extreme. So they go to the 14th row, degrees freedom. Again, they show you that 1.54 is between 1.345 and between 1.761. So you know the probability. You don't know the exact probability using the chart. You know that it's going to fall somewhere between 0.1 and 0.05, which is enough information to tell if you're going to reject or fail to reject your null. Because again, remember your alpha level is already going to be set before you start. And they explain that it's between the two. And so the p-value for this test statistic is between 0.05 and 0.1. Because the p-value exceeds the default of 0.05 significance level, we conclude that the company's new AAA batteries last longer than 30 hours on average. Does not. We can't conclude. There we go. It does not last longer than 30 hours on average. So remember, they tell you to use table B wisely using the chart. Gives a range of p-values for significance. We can, like I said, we can still draw a conclusion from the test in much the same way. We just don't have the exact p-value. The table B has other limitations for finding p. It includes possibilities for t-distributions for degrees freedom only 1 to 30. Again, with the issue, note that the degrees freedom isn't provided in table B. Use the lower degree freedom that is available. Remember, they're just reminding you to round down just like we did in confidence intervals with using the degrees freedom. Personally, I like using the calculator better just because you don't have to worry about making that judgment call. Again, they only show positive values, so you have to remember that the t-distribution is symmetric, so if you have a negative t-statistic, you use it the same way. You just look up the positive values instead of the negative. It'll still give you the same probability in the tail. Here it says, suppose you're performing a test with a null equal to mu equal to 0.5 versus not equal to, based on the sample size of n equal to 37. Obtained, and you get t equals to negative 3.17. Since this is a two-tailed test, you're interested in the probability of getting the values of t less than negative 3.17 and positive 3.17. So they're showing you that here, down here in the picture. Due to the symmetric shape of the density curve, since table B shows you positive t-values, we must focus on positive 3.17. So with 37 degrees freedom, they told you you're going to have to round down, so you have to use 30 here. And 3.17 is actually between these two right here, right? It's between 0.005 and 0.0025, and it's right here and somewhere in between those two. Oh, sorry, never mind, going this way through between these two. They remind you that it's not there, so you have to go across, and you're going to use this right here. And then corresponding the upper tail probability is between these two for this two-sided test and the corresponding p-value between. So we have to then double it. So they went ahead and rounded to this 0.001. Since it's between the two, they went with a higher amount so that when they doubled it, they got 0.002, and they can still compare it to alpha. And so they show you that it's 0.02, and then you have to double it here for those. So it kind of has a issue. When the conditions are met, we can test the claim about a population mean using a one-sample test. Here they are showing you exactly what I went through. Remember, you'd have to double your degrees or your area under the curve if you have a two-sided test. Use this test only when the population distribution is normal or the sample size is larger than 30 and the population is 10 times the size of its sample. Remember, the conditions have to be met. Alright, so if we look at this example,